is Justin Collins. Welcome to my talk. Thanks for coming. You can find me on the internet at President Beef, most places on the internet. This is a picture that I took in California, up the coast somewhere. There's no towns nearby, so I don't know how to describe where it is, but I'm very proud that I got the bird in the picture. Oh, it's not working. Well, anyways, I'm very proud of getting the bird because I saw it coming and I tried to take the picture. I'm very proud of that. Anyways, you know, they used to show, people would get mad because people would invite you over and then they'd have a slideshow of their vacations. No one does that anymore, so I put my vacation pictures in my presentations so you get to experience it. So today, talking about injection vulnerabilities in general. But first, about me, I'm this guy over here. I realize this is my 8th year of application security, and right now I work at SurveyMonkey, and I also work at my own company building Brakeman Pro. So if you need a static analysis security tool for Ruby on Rails, check out Brakeman Pro. If you need to take surveys, check out SurveyMonkey. So I'm actually a little bit nervous about this talk because it's more of a thought talk than a nice concrete talk about things that I'm very sure about. So I hope it goes well. And I did not pick this picture because of SurveyMonkey. I just thought it was a good thinking picture. But maybe it's something that just gets stuck in your brain when you work at a company that has monkey in the name. Anyway, so I looked it up, and it is claimed that 1998 is about when people started talking about SQL injection. And it is now 2018, which means it is 20th birthday of SQL injection. Yes. The interesting thing about that is it means that it's a very well understood problem, and we also have a very prescriptive solution to SQL injection, more so than we have for most other vulnerabilities, which we'll talk about a little bit more. But happy birthday to SQL injection. So if we look at the OWASP top 10, and we look at injection and also cross-site scripting, which I believe is also an injection vulnerability, but a more specific one. They've both been on the list since 2004. Injection started kind of low, and then it jumped up to number 2 in 2009, and then since 2010, it's been the number 1 spot. So again, SQL injection, been known since 1998. It's been at the top of the OWASP top 10 for about 8 years. And then cross-site scripting is bounced around. But you put those two together, that's a lot. That's 20% of the OWASP top 10 is essentially injection. If we look at the 2017 new OWASP top 10, this is what they say about injection. And I couldn't remember what these numbers mean, so I had a little cheat sheet. So exploitability, easy. If you know it's there, it's easy to exploit it. In fact, search the internet and you'll get all kinds of nice payloads. Again, especially SQL injection, very well understood. And people have thought a lot about it and written a lot about it. Prevalence is middle of the road. According to OWASP top 10, it's common. So not widespread and not rare, but common. Detectability, easy. Relatively easy to find in an application. And then the technical impact is severe. So of these 4 metrics, 3 of them are the worst they can be, and one's kind of in the middle. So that's telling us something about it. And obviously this is why it's at the top, right? So let's look a little bit at prevalence versus impact. I found the HackerOne report, and this is information from 2013 through May 2017. So maybe about 4 years worth of data. Cross-site scripting is the most common vulnerability found, which I think most of us would agree that makes sense. And then the more specific injections down here are not very common. Command injection, I know it's really tiny. Command injection, SQL injection, code injection are like, this is by industry, like 2%, 3%. A little bit scary based on yesterday's keynote. In healthcare industry, 6%, the highest of what they measured. So you kind of get the feeling of like, well, it's not like super common. Cross-site scripting is, but other types of injection aren't really super common. But again, it's at the top of the list, right? If we look at the bug crowd data, this is the 2017 report. These are critical vulnerabilities, meaning their top P1 category. This is what makes up that category, and 63% were SQL injection. So last slide is like not very common, but when it happens, it's bad. And cross-site scripting is number 2 with 18%. And I think XSS is often categorized not as a P1, so sometimes not. And they also said that SQL injection got the highest average payout, a little over $1,000. So it's not super common, but when it happens, it's bad. And I think that probably reaffirms most of our intuition about it. Okay, now let's talk about what an injection vulnerability is. And this is maybe for some of you, you're like, I know what an injection vulnerability is. This, so we're all on the same page, and we're all together on this. So this is, I think, my definition. Maybe someone else has said this, but this is my succinct definition. It's when we have data that gets interpreted as code. We have values that should be data, and data, you should not be executing data, but instead it happens, and then we have an injection vulnerability. And that data could be things like query parameters, values from a form, they could be values that come in as header values, files that are uploaded, stuff that comes out of the database. These are all things that should be data, and somehow they get interpreted as code instead, as SQL or HTML or JavaScript or CSS or Bash or a specific programming language. That's when we get an injection vulnerability. And it kind of, like visually, it looks like this. We have some code that's like from the developer, that the developer's intending to be interpreted. And then we have some code from the attacker, and then they both get sent to an interpreter of some kind and executed. Although actually it usually looks more like this, like the attacker code is kind of in the middle. And we'll see kind of the examples of that. And then again, it gets sent to an interpreter. And in this case, what I mean by an interpreter is like anything that's going to interpret that and sort of execute it, right? So that could be the database, it could be a browser, XSS, which is generally going to be the browser. Could be the web server, a mail server. It could be a shell. Could be the templating library or XML part, you get the idea. It's something that's going to execute this code. Or maybe, someone's just calling eval on some code. All right, so here's our classic SQL injection example. We're creating a query, and we're putting some data into it, and then we're going to execute the query on the database. And so, just to be like super explicit here, we expect that email address to be data, right? And we have this string which kind of looks like data, like in the program it's data, but actually we're going to execute it as code, right? And that email is probably going to be user input. So in this case, like a request parameter. And if it's user input, that means it can be attacker input. So we have, again, sort of the classic SQL injection, where we're going to end that string and do or 1 equals 1 in the query. And what ends up happening is we had this code that a developer wrote, right? I'm talking about the SQL code that the developer wrote. And we have this data coming in, but now the data is interpreted as code. And what I think is really interesting is at this point, we no longer have a distinction between what the developer wrote and what the attacker is injecting. So at this point, we've lost, right? We have no idea which is which. So here's some more examples in different languages where we're building queries and then we put values into them and we have SQL injection opportunities here. So if we look at this, we see like we're building strings and we're like putting values into those strings and then executing them, right? Here's more examples. Wow, I don't know what happened there. Lots of white space in that top run there. So again, we're like building strings, and this time we're going to hand them off probably to a shell, or sometimes it's like a pseudo shell, and it's going to execute. So here we have command injection. And just in case you didn't get it on the first two slides, here we're building more strings, and this time we're building actually templates that we're going to execute. So if you caught Jason's talk yesterday, server-side template injection is becoming more popular among bug bounty researchers. I think the Rails example on the top is actually very sneaky because there's nothing that really indicates what's going on. But when you do render inline, it actually treats it as your default templating library, which in this case would allow you to put in essentially any Ruby code and it would be executed on the server. So what we get from, hey, I'm like building a template, now we have remote code execution. And again, we're like putting together these strings, putting user input into them, and then handing them off to something that's going to execute them. All right. What about this one? So is this like opportunity for cross-site scripting? Probably, but you don't actually know because there's like a whole bunch of templating libraries that use this exact same syntax. But what I want to point out here is we have at least 4 different contexts that require different types of escaping to avoid cross-site scripting. At the top, we're just kind of like in an HTML context. Here we're in a CSS context. Here we're in a JavaScript context. Here we're in HTML attribute context. It's very unlikely that your templating library even offers the correct escaping for all these 4 contexts, and there are like 5 or 6 that can happen in HTML, right? So even if you wanted to do the right thing, probably not going to be able to. And of course, expecting people to always use the correct encoding for the correct context is very difficult. This is like a simple example, but most of the time, your templates aren't going to be this simple. Okay, we'll come back to this. So here is my thesis for the talk. Web programming is actually metaprogramming. And in this context, what I mean by metaprogramming is you're writing code that writes code. There are other parts of metaprogramming, but in this context, this is what I'm talking about. This is what you're doing when you build a web application. If we look at that, the black box with the glowing blue lights, that's our web application on the web server. And if you think about what it has to do, it has to take in some stuff from a browser. We get an HTTP request, opportunities for injection there. Maybe some JSON, some XML, form data, query parameters, all of that's coming in. And maybe it's talking to some backend microservices, maybe it's talking to a database. And then from all of that, it has to generate something that gets sent back to a browser. It's going to be an HTTP response. And you're probably going to have HTML and JavaScript and maybe some JSON and CSS. So it's essentially taking this and generating code. And that code's going to be interpreted. Actually, it's interpreted in the browser. There's also like things along the way, right? There's the web server itself. There may be networking devices along the way, all of that. And then you have the browser itself. And in the browser, you may also be like having JavaScript that generates HTML and CSS, and maybe it's even generating other JavaScript that it then interprets. So there's a lot of code generation happening here. So really, web programming is compiler construction. we're building a compiler that's going to take in inputs and is going to generate code that's going to go and get interpreted and evaluated. However, unlike most compilers, we're doing it with untrusted values that are coming in. And that just makes it even harder. So we have this like complicated system where we're building this compiler, and we also have to worry about people giving us values that are untrusted and unsafe and handling those all correctly to generate safe code for our users and for our backend and so on. And I like you to just like kind of take that in for a moment, because this is the root of injection vulnerabilities, is that this is what you have to do when you're building a web application. And that's a lot to deal with. So if we look at how you would normally build a compiler, you would start off with some source code, which, by the way, is probably trusted source code. And at that point, you take it in, you turn it into a stream of tokens, then that gets turned into an abstract syntax tree, then you kind of turn it into like another tree, but it has more semantic information. Then that gets run through a bunch of iterations of intermediate representations, and then at the end you have compiled code, either binary or some kind of source code that gets interpreted. So I just want to point out that at the top we have text, and at the bottom we have text or binary that comes out. In the middle, when you're making a compiler, you don't deal with text. You're not manipulating strings unless you're really inexperienced at writing compilers like I did once and tried to do it with string manipulation. And it's a mess. You don't want to do it. It's very hard. But that is what you do when you write a web application. You're actually building a complex compiler, and most likely you're doing it all via string manipulation. We have our templates, we have our queries that we send to the database. It's all strings, string manipulation. That's why I showed you all those code examples. It's all building up strings that you hand off to an interpreter. And again, we're doing it with untrusted values. So that seems like a great way to get vulnerabilities, and it is. That's why injection is at the top. Just to reiterate, we're building these complex systems using string manipulation with untrusted values. All right, so back to the real world. What are the suggestions for preventing SQL injection? You could use an ORM, and if the ORM is good, right, it should help you avoid SQL injection. However, first of all, you have to have like the object mapping, and not all applications make sense to have an object mapping. Not all queries make sense to have an object mapping. And at some point, developers are going to want to write just like a normal SQL query that doesn't, again, have this mapping. So even if you use an ORM, there's probably going to be a method somewhere where you can just shove in some SQL. Query parameterization is generally like the most commonly recommended way of preventing SQL injection, right? And it mostly works, except first of all, you're still doing string manipulation, and it tends to be limited on where you can put these placeholders. If you put them like a column name or a table name, it may mess up the query and not really work, right? And again, we're like doing string manipulation. And then, of course, if we're just manually escaping things, first of all, we have to make sure we call the right method to escape the right data. So now we're back in like XSS land. And we're building strings. So I think I've probably like hammered that point home enough, right? Like we're building strings. And that's bad. So here are my suggestions. And this is where we get into the like thought part of like, a little bit vague. So here's my first suggestion. Let's stop providing unsafe interfaces, right? So you're building an ORM, and then you say, okay, I have all this great like object-oriented stuff that you can do, but I also have just like, execute SQL. And at that point, how are you going to execute the SQL? It's going to be like a string that you pass in, and now you're basically saying like, yeah, I offered you all this good stuff, and here's the way of like introducing a vulnerability again. So some examples, stop providing, execute this query. Maybe stop providing, hey, like, here's your shell, like execute whatever you want. And in these cases, I'm talking about like where you can just pass in a single string and it will execute. Rails, HTML safe is not safe. A lot of templating languages like Jinja, they have like safe. Again, it does the opposite of what you mean. So let's stop providing those kinds of interfaces. In fact, for templating languages in particular, one thing I've noticed is often missing is that people want to compose templates, right? You want to reuse templates. And if you don't have a good built-in way of saying like, okay, here, I'm going to combine this template and that template and that template, then people do stuff like this, where like the template value comes in as a string, and then you throw it in something like this, and you're like, well, I can't escape it because I just generated a bunch of HTML from this other template, so now I have to mark it as safe, and it's just a poor way of composing templates. So provide better interfaces, inner HTML, just stop doing that. Another thing I want to mention is that any library that you write is probably going to end up being used on the internet at some point. And I think we've seen a lot of examples of this where, especially older libraries, someone goes, oh, well, I need this to, process this file, or maybe I'll shell out to it because it's handy and it's useful. Now, the original library author probably didn't even consider that, hey, maybe this might accept untrusted input at some point. So as we're writing libraries, we have to think about like, hey, maybe at least the default interfaces should assume that it could be dangerous input that's coming in. Okay. Number 2, stop providing string interfaces to libraries. So it makes sense as like the first pass, right? But SQL injection, as mentioned earlier, been around for 20 years. Maybe we should stop building database queries by putting strings together. Here's an example from the Rails world. I'm not saying this is like the best way to do things. I'm just saying this is kind of give you an idea. Instead of manipulating strings, we're kind of making these method calls, and everything that gets passed in is going to be treated appropriately in the query. So we can pass in untrusted input here, and it'll be properly escaped, and it will generate the query for us. So we're not working at the string level anymore. We're like at least one step up from there. But developers want to write stuff like this. Not just developers, everybody. Everybody wants to write code like this, where I'm like, well, look, I am an expert, and I need to do this complex query, and I want to be able to generate it dynamically. So one thought that I had, and I think this is a very good thought, which is why I'm sharing it with you. So, and I'm sorry we're getting like Rails heavy here, but it's like where my experience is. If we have query parameters, and our framework knows that it's a query parameter, right? And we try to put a query parameter into a string, well, maybe our query parameter shouldn't be a string type. It should be a query parameter type, let's say. And if we try to even put it into a string, we should get an exception. So this kind of is like, hey, if you try to build up strings using unsafe input, we're just not going to let you do that. And I think this has a lot of promise because, again, the framework already knows the types of these values, right? It knows that this came from a query parameter. So if we just say, well, you can't add query parameters to a string and don't offer a toString method, okay, then we kind of eliminate this. And instead, we have to offer a safe interface for composing query parameters or form values or whatever, and database queries. It's just a thought, but I think it has a lot of promise. This is ancient. Does anyone remember? Does anyone know what Markaby is? No, because you're not, huh? No, sorry. So a long time ago, there was a guy in the Ruby community named Y the Lucky Stiff, and there's like I can't remember the publication, but they did like this whole big article on him when he disappeared. Anyways, he had this library, and I don't know that this is a great idea. It didn't really catch on, and it's very like heavy. But the idea is like, I'm composing HTML, but I'm not working with strings. I have data values, and I have method calls that I'm making, and then that will generate the HTML for me. And again, I'm not saying this is a great idea, but the idea is that what can we do that is not manipulating strings, but still gets us to generating those values safely at some point. So it's a thought, and like I said, it's a thought talk, so it's just a thought. I'm sure some of you can come up with like a better way to build this kind of interface, but the idea is to get away from like strings, right? Number 3, if you're going to be accepting code, let's say a database query, or even like a shell, like shelling out somewhere, do you need like the full power of a programming language in that particular scenario? Like, do you really need a Turing complete language, or can you restrict that language in some way? Because the more you restrict the language that you accept, the more you eliminate potential vulnerabilities. I think a good example is HTML. If you only had HTML, but no JavaScript, no Flash, anything like that, you're kind of limited in what you can do. You can do like some content injection maybe, you know, but you can't really execute code. You don't have the opportunity to like have a Bitcoin miner in an ad, right? It's just, you can't do it. Or if you can, you should probably give a talk on that, because that would be really impressive. So again, it's just like a thought that if you're building an interface, you know, if you're building a library or an interface, generally you're thinking like, I want to provide the programmer all the power that they could possibly need. And then it's their job to figure out like how to use it safely. Maybe think about it the other way, right? What do I have to expose and what can I leave out? Another good example is if you're creating a database library, do you need to allow multiple queries to be executed in one call? Because a whole lot of SQL injection payloads rely on being able to get a semicolon or a new line in where they can end your current query and execute a second query. Those kinds of things are ways that you can limit the impact if a vulnerability occurs. Okay. Number 4, provide context-aware escaping. So now we're going back and we're like, hey, we're going back to strings. Because honestly, you're building an HTML page. It's a whole bunch of, you know, text. It's a lot easier to just like write the HTML and then put dynamic stuff in it, right? So, okay, giving up on the other ideas, let's go back to, okay, I'm going to build strings, but how can I do it safely? So going back to this, all those different contexts, what we want is to be able to hand this to our templating library. And again, we're like writing our HTML, we're even doing things we probably shouldn't do, like inline scripts and inline styles, you know, dynamic URLs and so on. And we're like, look, I'm just going to write it the way I want to write it, and then I'm going to hand it off to my templating library, and it's going to do the right thing for me. Because honestly, remembering all this and doing it correctly in all cases is just, it's too much. Even if you have the libraries available to do it, which is also not often the case. Okay, so there are at least 4 libraries that do this. The HTML templates that come with Go do this. There's C templates from Google. Is anyone familiar with C templates? No. They didn't seem like super well maintained to me, but they're out there. Also, if you use them, the auto escaping is turned off by default, so you'll want to turn it on. Latte looks really cool because it's PHP, which PHP normally you're like, here's a bunch of HTML and I'm going to put code all over inside of it. So it will actually like do the right escaping for you unless it's a script context or maybe CSS. But for the other contexts, so you have like your PHP tags, it will automatically pick the right escaping for the right context, which I think is pretty amazing. And then there's secure handlebars, which was presented actually at AppSec USA, I believe 2015. And it same thing, like it looks at your whole template, parses the HTML, and does the right kind of escaping for the input that you're putting in. I think this is fantastic. And it's great that there's, and there's probably more, you might know of more, but these are the ones that I found. So what if I wanted SQL context-aware auto-escaping? I couldn't find anything like this. And I think if you watch the talk about secure handlebars, the majority of the talk is just like, how do we parse HTML? How do we parse the templates that people use in a way that, you know, we can do the right kind of escaping and people aren't too restricted on, you know, they don't have to use like XHTML or whatever. If you go look for SQL parsers, you will find that it's also a very hard problem because every database has like different syntax and different commands and different ways of escaping. And what I found is that it seems like this sort of accepted approach is just rip the parser out of the database itself. So like if you're using Postgres, like just take the parser out of Postgres and try to use that. And if you're thinking like, okay, well, I need to modify the parser so that I can put, you know, question marks or brackets or something in so that I can put the values in, like we saw in the other templates, that's really hard. Like that's a hard job. So it'd be great if any of you could tackle that problem. You can come back next year and give a talk on it. That would be awesome. What about shell context-aware auto-escaping? You will not find anything about that. Of course, every shell is like a little bit different, and just like no one, as far as I know, no one has even like approached this problem, right? And again, it's a hard problem. It's a parsing problem. It's a how do I escape properly problem. All kinds of difficulties to build these auto-escaping templating things, right? So I'm hoping that some of you in here are thinking, hey, the framework I know does this, and that is cool, which is also a town in California, if you didn't know, like I didn't know. But so that's great. Like it's awesome that there are frameworks that are doing that correctly. Or I shouldn't say correctly, but that are offering that kind of functionality to prevent injection issues. However, what really we need is that every framework needs to provide this. So can you imagine somebody today is like, okay, I'm going to build a web framework, and they build it, and they don't provide any kind of HTML escaping. That would be ridiculous, right? Everyone would kind of like laugh at it, right? Because that's just silly. You know that you need to have some way of escaping values. If you build a database library and you don't provide at least query parameterization, people are going to be like, what is this, right? So we need to move to a space where things like context-aware escaping is just expected. I expect that my templating libraries will do this for me. I mean, not in a way, I don't mean that in the way of like you don't check and you just blindly use things. I mean like this should be the level that we're expecting from these libraries. As well as, like I said, the context-aware stuff is really cool. And it's great because you can kind of continue doing things the way you're doing them now. But even better would just be moving away from the strings and having a higher level interface that we're working at. Just like I said, with compilers, you're not going to be working with string manipulation. So we need to be moving to some kind of libraries. And again, it's a thought talk. So I'm hoping that you have thoughts on like, yeah, what kind of interface do I want to use it's not strings. I don't want to like be putting strings together, but some kind of data structure or some kind of programming interface that's going to be safe and still allow me to do like complex queries that I want to do. And again, we want every framework to do this. So I have some thoughts about how. I think there's a really good model with like the libnacl and the libpasta library that came out recently, where people spend a lot of time building a secure by default library that does the right things, that's simple in terms of its interface, and then everyone else just wraps that library. I think that's like a really cool model because you put all the effort in one place and then everybody benefits from that. As opposed to like, okay, well, now every framework has to like go and implement their own whatever, context-aware escaping. Again, like I said, sort of like expecting better things from our web frameworks, expecting that they're going to provide really good security, and in this case, like context-aware escaping or a better interface for doing SQL queries, that kind of thing. And then my thought is like, so Google created Go, right? And now like a whole bunch of people use Go. Because Go is so awesome? Maybe. Or maybe because Google has an awesome marketing machine and they can promote it and people trust it because it's Google and then it catches on, right? Or think about like Rust with Mozilla. And I think those two examples are great because getting people to use a new programming language and getting community around it and getting people using it is like a hard thing to do, and yet we've seen really modern examples of that happening. So, and same with web frameworks. You would think like maybe the web framework market is flooded, but no, people still keep coming out with new ones. And if you have somebody with the money and the influence and the incentive to get people to use it, I think there's opportunity for change there. So who here works at Google, Facebook, any of those large, Amazon, like any large, nope, nobody? All right, well tell your friends who work at those companies to get on this. And then, just applying some shame to frameworks that are not doing it right? That are not providing these security features, I think could be helpful. All right. So who in here is like, this sounds a lot like LangSec? Were you thinking that? A little bit? Yeah. So I spent some time, so LangSec stands for Language Theoretic Security. It's a research area. And I spent some time looking at it, and so if you're really familiar with it, you can correct me. But I got the feeling, so the early work is definitely focused on like parsers and building safe parsers that can accept unsafe input and so on. I didn't see so much around what I'm trying to talk about, which is like the programming interfaces that will allow you to do things safely. If you want to check out, I know it's not a great URL, you could just search for LangSec. There's a bunch of papers and stuff, and maybe you can come to your own conclusions. I feel like this is a related area of sort of formalizing, parsing of languages and also output encoding. But I feel like maybe it's like a little bit off from what I'm talking about specifically. But I needed to mention it because it's definitely an area it's nearby. All right. That's all I wanted to talk about, but um, I, I, it's a thought talk, and I think you might have thoughts. So I think we have plenty of time. I think. I don't know. But I would love to hear people talk about libraries that are doing this, or like thoughts that you have on this. Not necessarily. They don't have to be questions. Right here.
I just have a comment because I'm not an app programmer or developer. I come more from the security side, right? And many times it's difficult for me to believe how many mistakes I find and so forth. But then when I watch how, like, I took the picture of the 4 different ways that you would have to escape characters in one little template, and that's really ridiculous.
Yeah.
Wow. Yeah. That's quite enlightening. Thank you very much.
Oh, okay. Yeah. And again, there are more than 4 contexts, even in in an HTML page. So.
So you, again, coming from the security space, your example on query parameterization,
Yes.
I can say is definitely SQL injectable because you're doing string building, right? And you focus a lot on string building being the problem with injection. But the idea behind proper query parameterization and parameter binding.
This one?
Yes.
This is safe.
Is it?
Yeah.
What language is that?
It's Ruby on Rails.
Active. Okay.
Yeah. But
you had another one that was in Java, I thought.
no. I had a vulnerable version.
Could be. Okay.
Yeah.
Maybe that's what I'm remembering.
Yeah, it could be.
But the problem that we see a lot is even with building parameterized queries, right, without separating the parameter itself, right, the variable from the query, you still have entirely injectable queries, right? Doing parameter binding is that exact thing of not building a string. You're feeding the object into that query,
Right.
rather than the string of the object.
Yeah, I see what you're saying. Yeah, I do. You're right. It's separating, like, okay, I have this string, and I have the values are over here, and then the database driver will put those together safely. Is that what you're saying?
Yeah, more or less, yeah.
And I that's true. But I think 2 thoughts on that. One, we only get query parameterization for database queries. We don't get it for templates usually, and we don't get it other places. So it's great that we have it here, but we don't get it other places. And really what happens is, like, people sort of get into this, like, yeah, query parameterization, and then they want to do something like a dynamic column name. And most query parameterization will not properly parameterize a column name or a database name. So you still end up with people like building dynamic strings on this side, and they'll also do query parameterization in the same line of code, right? So I'm not saying like this is awful. I'm just saying like maybe we need something else. Yeah.
Yeah, it's one of those things where you need to understand the limitations of what it provides.
Right, and the thing is, I am a security professional. Yeah, okay. I am a security professional, and it's still like confused. Like, you still have to like spend some time to understand like what are the safe ways to do things. And if you're a developer, I'm not saying you wouldn't do that, but when I'm writing code, I just kind of like Google for like the first thing that comes up, and I kind of trust that like it's doing it right. So yeah, it can be tricky, even if you have the tools available to do it the right way. And yeah, I'm like, okay, I'm going to do query parameterization, and then you find like, well, but if I do the parameter in like the wrong part of like a particular part of the query, like it doesn't do it right, and it breaks my query. And now I'm stuck with like, well, how do I do it right? So that's why I'm kind of suggesting like even then you're still kind of like putting code in strings and then trying to manipulate them to have dynamic values and so on.
I think that those examples are really great up there. But a lot of the issues that we had at my company were that people started writing SQL functions inside their Java code. And they weren't necessarily like SQL statements, but these functions had these statements inside them. So they added parameters from the request into these SQL functions. And not a lot of developers, and even security folks in this conference, knew that you can actually create callable statements. And so that was very interesting to figure out that we had to create a wrapper that did parameterize those statements. I think I would like to see more examples of that in the future, like people stating that.
You mean statements like prepared statements? Or
Callable statements, so like they had SQL functions under,
oh, okay.
not
Yeah.
like SQL queries, but these functions were like PL/SQL calls.
I don't think you mean stored procedures.
Not
I mean,
stored procedures.
I mean you mean like in SQL you can call certain functions that
Yeah.
are more like executing
Yeah.
code than they
Yeah,
are
yeah.
querying the
Define
database.
functions, exactly.
Yep, certainly. And also stored procedures can have dynamic bits to them too, which is like if you're looking at the code, you're like, well, it seems okay. And then you look in the database and it's like, oh, actually, no, it'll just like accept things and like put them in dynamically. So again, another problem. Oh, yeah, right here. Wait for the mic, please.
Thank you. I would like to agree with the first statement we heard that there are a lot of maybe what I'd call cases of over-trusting input. I know in security with a lot of the development teams I've worked with, people basically say there's no injection prevention, but it's okay because we trust our source. I guess maybe I'd like to confirm explicitly that what you're getting into with the don't just DB execute whatever, don't whatever, that's kind of like a library without protections. It's a what is this case. Would
Yeah.
you sort of agree with the sentiment?
Yes, absolutely. And
Okay.
you know, if the mic can go back there. Yeah, that's absolutely true. I can give you an example at a former employer. They had external data that they bought from some other company, and then they took that data and they just put it in their database. And then when they started rendering it on the web page, hey, here's like a bunch of SQL injection that came in from that. So they may have been doing, well, they obviously weren't escaping things properly on output, but in terms of, you know, maybe they're managing all the data in their database, everything going in and out. They're like, yeah, we're doing this right. We're like very careful about what goes in. Maybe, I don't know, maybe they were like sanitizing it or stripping whatever they were doing. But then they have a third-party source of data, which they just put into the database. And now, I mean, that's untrusted input. It didn't come in through a query parameter or from a user. They literally bought it from a third party. So, was there a question? Sorry.
Yes, I have a question here in the back. First of all, thank you so much for your talk. I'm a college student studying CS and security. And just correct me if I'm wrong, but from what I'm understanding, these like libraries are kind of a way to prevent these injections from happening at the code level, from the development level. Is there a way to somehow use these libraries to maybe run a scan on code that would, you know, catch these, you know, unparameterized or statements that are not prepared properly as maybe like a security testing,
Yeah.
automated security testing, or is it mostly this is just like we're trying to stop it from the development standpoint with the language, with the framework?
Yeah, so certainly, I mean, I have a lot of background in static analysis, which is what you're talking about. And if you remember at the beginning, OWASP Top 10 categorizes injection as easy to detect. And actually, it is one of the easier things to find via static analysis looking at the code. The problem is we don't have 100% coverage on every language and every framework and every database library that we can have that kind of assurance. And really we should, and you know, is every company going to get the tool or buy the tool that's going to cover their particular thing? And maybe they wrote their own, who knows? So yeah, I think, you know, fixing it at the library level, well, and actually let me back up just a little bit. Again, the 20 years of SQL injection, we've also had static analysis and dynamic analysis tools, and they can find this stuff, but it's not solving the problem completely. It solves it in individual cases. And the idea here is like, let's just kind of try to solve it in, at the base layer. And there are other ways of solving it. Yes, there's a question here. There are plenty of other ways of solving it. This is just some thoughts.
So, quick question I had is for libraries, secure control interfaces. We have the OWASP eSAPI, right?
Yes.
So, does that like you talked about Google or Facebook coming up with libraries, but how are OWASP eSAPI libraries? We use that a lot with reference implementations.
So my understanding, the way I would look at it is libraries like ASAPI should be, like that's something you can build a better interface on top of, right? So if you have stuff like ASAPI, or there's another project I know Jim Manico has been working on, I don't remember the name of, where they're basically providing the building blocks in terms of these are the methods that are going to do the correct escaping. But you have to wrap those up and in a better interface. So like I was talking about like the context-aware escaping. You need to have good escaping libraries to do that, but you don't want the developer to have the responsibility of choosing the correct method. In some cases, if you look at like the OWASP XSS cheat sheet and so on, sometimes you have to apply multiple encodings to the same input to make it completely safe. And who's going to remember that in all cases? Like you'd have to like print out the cheat sheet and like have it on your desk, right? So the idea would be to take, potentially to take a library like that and then build something on top of it. Yeah. Yes.
It's just kind of it goes back to our keynote yesterday in the morning. What you have talked about is great, and I think we need to put that more into the mindsets of the generation that's through that pipeline of education, and get these concepts into their heads to write code more securely, and kind of share these kind of thoughts with them.
Right. Yeah, I think that's part of. If you think about, because one thought I had was like, okay, so like, if you're building a new framework, you should do this, right? And then I thought, well, who's building new frameworks? And it was like, well, actually, people build new frameworks all the time. And it's surprising how rapidly those new frameworks can be adopted. So yeah, I agree. Well, I mean, I don't know how to implement exactly what you're suggesting, but definitely the sort of like I said, like, hey, this, if you're building something, if you're building a web framework, you have to provide these things. And you see that, for example, with CSRF protection. Most new web frameworks are going to provide that out of the box. They're going to provide that for you. And so that's something that we should just expect. Like, hey, you're building a new web framework? That's awesome. Do you have CSRF protection? Do you have XSS protection? Do you have SQL injection protection? And so on. And that should just be what? Yeah, it should be given that you're building a web framework, this stuff is provided. Okay, I think that's about it, but I'd be happy to talk to anyone afterwards if you have thoughts. All right, thank you.